Good morning everyone. My name is Yashashwan. My roll number is 24BQ180402. Today I will be presenting a seminar on operations on signals, a fundamental concept in signals and systems. We will explore different operations that can be applied to signals in both time and amplitude domain. First, signals are the way information is represented in engineering systems such as audio, video, and communication signals. To properly use them, we often perform certain operations. These operations are classified into two main categories: time domain, and amplitude domain. In time domain, there are three properties. They are time shifting, time reversing, time scaling. And in amplitude domain, amplitude scaling is as present. Time shifting means moving a signal forward or backward in time. If we delay a signal, it appears later. If we advance, it appears earlier. This is widely used in synchronization tasks in communication systems. This is time shifting. This is the actual signal x of t and t. If we delay the signal x of t minus 2, so the signal will be delayed. And if we do x of t plus 2, the signal will be advanced, as I said before. And then we go to time reversing. And now time reversal. Time reversal or folding flips that signal in time. Imagine watching a video in reverse. That's exactly what time reversal does. The operation is especially important in convolutional time analysis. Time reversal means actual signal gets reversed. This is the actual signal we have, x of t and in t. The reversed signal will be denoted as x of minus t. It will be get represented like this. If we take x of t minus t plus 2, whereas t minus t plus 2 equal to 0, t equal to 2. At t equal to 2, the signal will be ends from minus 1 to 2. This is what we represent the signal. And we come to the time scaling. Time scaling changes the rate of signal. If we compress the time, the signal plays faster. If we expand the time, it plays slower. For example, in video playback or speech processing, scaling is often applied. It will be represented as a of a greater than 1, it is compressed. T is in between 0 and 1. Then the time is expand. This is the actual signal we take. that we take x of 2t, then the signal gets compressed. The furtherly we have minus 1 to 3. Now we have minus 0.5 to 1.4. The signal gets compressed. Then if we take x of t by 2, then the signal gets expanded. From we get the signal as minus 2 to 6. Then the time gets expanded. Now we head to the amplitude domain. In amplitude domain, time scaling happens. For the time scaling means changing the signal's magnitude. We represent it as y of t is equal to a into x of t. Amplitude scaling adjusts how strong or weak a signal is. Increasing amplitude makes it louder or strong, while reducing it makes it weaker. Think about increasing or decreasing the volume of a sound. That's amplitude scaling in action. As example, amplitude scaling, we take this as original signal x of t at amplitude 2 and minus 2. If we change the amplitude 2 of x into t, as the amplitude changes as 4 and minus 4. This is called expansion of amplitude. And we multiply with 0.5, the amplitude range is 1 to minus 1. This amplitude scaling is called tangential. With this, we also have addition and subtraction of the signals. Addition and signals can be also added or subtracted. This happens point by point. For example, when two sounds waves overlap, they add together to form a new wave. This principle also used in interference pattern. As the addition of signals is represented as y of t is equal to x1 of t plus x2 of t, and the subtraction is represented as y of t is equal to x2 of t plus x1 of t, x2 of t. Application. It is used in interference and superposition. As addition and subtraction, we also do multiplication and differentiation and integration. As multiplication, we represent it as y of t is equal to x1 of t into x2 of t. As it is called amplitude modulation as AM. For differentiation, y of t is equal to dx of t by dt. It represents the rate of change. Example, velocity from displacement. And for integration also, y of t is equal to integral x of t dt. This is called accumulates signal. Example, energy calculation as and vice versa. This is today we have discussed about operations on signals. These have of the two types, time domain and amplitude domain. We have discussed about both and the applications also. Thank you for giving this option.